Chapter 9, Looping Structures. Hello everyone, and welcome to another lecture on the 5th edition of Browning's Introduction to Programming with Python, and Sebastian and I are here to talk to you today about looping structures. This is really one of your, your three basic structures, so we're learning about the last one now at this time. Looping structures allow you to perform an operation repeatedly based on either the truth or falsity of a pre-existing condition. So really this is somewhat similar to the old if and the elif statements. It's looking for truth. If the condition is true, the loop runs, it checks again. Is it true? It runs again. If not, it stops. So for example, if you were to use a debit card or ATM card to get some money out of a teller machine, you might stick the card in. If you enter your code wrong one time, alright, it asks you to enter the code. You enter your code again incorrectly, it's basically going to let you do it 3 times before it either takes your card or it locks your account and says, please see the bank, this isn't going to work, danger Will Robinson. Okay, that is a counter situation that's been written into the code, and it runs 3 times. Alright, so let's talk about some handy things and how we can use a loop. As an example of a loop, you might initially have a counter set equal to 1, and then the loop would perform a task, increase the value of the counter by 1, which is pretty important. We'll get to that here in a minute, and then reevaluate the loop condition. This is known as counter controlled loop. It is known at design time how many times you're going to run it. It's going to run 10 times, alright? So it's going to increment, move on from there. Errors that you might get with this is you forget to increment the counter, or you decrement the counter. So it'll never get to 10, it's always going a different direction, and it'll run infinitely, which is probably not what you want. The second type of looping structure that we're going to look at is something called sentinel controlled or flag value controlled looping. And with this, the loop could run an infinite number of times, but it's looking for a certain key, sentinel, or flag value. For example, enter values, when you're finished, enter a -1. When it detects that a -1 has been entered, it'll stop the loop, and that'll be the terminating condition. But let's look again at our counter-controlled repetition with our pseudocode. Set the counter equal to 1, while the counter is less than 3. Print the value of the counter, add 1 to the counter, go back up, check it's still true that it's less than 3, print the value of the counter, add 1. It would need to be important to note that when the value is false and it's checking at the top, it will stop all operation of the loop at that time. It won't move on. So we're going to try a while loop with Python. Key in the example, and we're setting the counter equal to 1. And basically it's going to run for a count of 1 and 2, but when it gets to 3, 3 is not less than 3. It's equal to 3, so that's not a true condition, and it won't go any further. Hit pause, try the code out, and then resume when you get that completed. Alright, examine how this works. Change the loop so that it's a 0, 1, and a 2 print instead of a 1 and 2 only. How would you do that? Well, you could set counter equal to 1. Or 0, and then that would solve the problem. Now, loop variations. Python supports only for and while loops, but there are different types of loops not supported by Python that other languages support, which are important to note. As such, what we've been working with right now with a while loop, while counter is less than 3, this is checking for truth or falsity at the top of the loop condition. However, you can have conditions with looping structures with other languages that check at the bottom. For example, do the following process, and then at the bottom, check to see if it's true or false. Well, with those structures, they're going to run one time whether they're true or false. It could be that you had a condition, for example, with that last chunk of code, you could have said counter equals 100, and then you said while counter is less than 3, 100 is not less than 3, it's never going to run at all. With a do loop while, it's going to run one time regardless of the truth or the falsity. And the do loop until, those work the same general fashion. All right. Again, other languages. Visual Basic is a good example of a language that supports several different types of loops. Let's see here. Loops that Python directly supports are for loops and while loops. That's what we want to look at. Let's look at a for next loop. All right, and there's some different variations with different languages depending on how they work. For integer, counter is equal to 1, counter is less than equal to 5. Perform the next statement block of operations. Next, in other words, increment it by 1. This is an important part to note, that what you're going to find with looping structures, whether they're for loops or while loops, they will be whole number counting, whether it's up or down. Whether you're going up to 10 or from 10 down to 1, it's going to be whole number steps. You're not going to have fractional values or floating point values in a looping structure. Important point, note that. Let's try a for loop, and this would be known as an enhanced for loop in some other languages, but Python being a rad language kind of enhances things automatically. Fun with for loops. In this example, how Python handles a for loop. X is implicitly declared to be 0, and it counts to 4, so 0 through 4. All right, and if you'll note, there's a 5 there. There are 5 values 0 through 4 because 0 counts as a value, so that's where you're getting 5 from. So try that out. For x in range 5, print x, and it's going to automatically increase by 1. All right, very good. Let's try more with the for loops, where we set a specific example that we're counting to. Note we've been very descriptive with camel casing with our variable names. For I in range to count to, which we said was 5, print I. Try that out and then hit resume. Very good. The range function is also kind of interesting. If you want to look, you can do slices of different numbers. For example, we could go 1, 7, which is going to loop values 1, 2, 3, 4, 5, and 6. Range 11, 8, -1. Basically, it's going to go from 11 to 9. Try out the examples with that you see on the range using some different like counting down, which is an optional parameter that you can put in, and then try the challenge out. Have it count down by 2 instead of by 1, and then hit resume when you're ready to continue. Very good. So X range is going to work basically the same way. You can try out the example of that and see how that works. And the most interesting thing that I want you to try out as well is you can actually loop through iterable or loopable structures. We're going to get more on this very quickly, and it's going to show you some real power with Python. But for example, we have a list that has items in it. It has an A, a B, and a 3. All right, those are the 3 list items. You can iterate or loop over the items in that list. For item in my list, then print it out. So what I want you to try as well is to traverse a string. We have a string called first, last, and middle. And then for character, which is just an argumentative thing, it could be for Sebastian in my string. Print Sebastian. Try that out and then hit resume. That was pretty neat. You definitely want to dog-ear this page, because this is one of the text processing capabilities that you can have a lot of power with in Python. You throw in some looping structures and some if statements. You can look for parts of punctuation. You could actually have something like this go through a series of sentences and look for a period, count the number of periods. We know that sentences end with a period, and it could tell you how many sentences were in a paragraph. And if you've used Word or OpenOffice or some different word processing packages, you may have used some of the grammar tools to actually get a reading index, or find out how many sentences or different word count in a document. Well, Python can do that for you. Pretty neat stuff. Alrighty, let us look at definite repetition. Again, we know how many times this is going to run. We have counter is equal to 0, and then we have my counter is equal or is less than 10. Print my counter, add 1 to the loop counter variable, because that's very important, otherwise it wouldn't get out. Try that out. Alright, moving along, we'll continue along with indefinite repetition. Indefinite repetition is pretty important, because with that, you don't know how many times it's going to run. So if you'll note on the example, we have while counter is not equal to 999. we've told the user, go ahead and enter values, but when you're done, enter a 999. That's our termination or flag value. Hit pause and we will move on from there. Alright, the next example we'll look at is loops within loops. You can certainly have a loop within a loop. This example, it's going to print a triangle with asterisks. You need to watch your spacing. You also need to note that there's a comma to suppress going to the next line. And you can take that out and run it and see that it's going to look pretty gnarly. It won't look exactly like what you want. But try out the example of a loop within a loop there. And then let's try the next example. We also have print a square. Alright, try printing the 10 by 10 square. Hit pause, play when you're ready to continue. Alright, endless loops. Again, we said that you could get in a situation where you're not incrementing the variable, you forgot to do that, you're decrementing it instead of incrementing it, who knows. That's known as an infinite loop. I do want you to see how that works. You will need to use Control-C if you're using idle or command prompt to get that to stop. If you're using something like NetBeans, you'll actually close the window because it won't be able to grab a Control-C character. But try that out and at least you'll see how it works. Next example, we have three handy built-in functions. These are Python 2 only, but they do work similar to loops, and they do the same operations. With Python 3, they have discontinued some of these, so this is a Python 2 thing. But map, filter, and reduce. Pretty interesting stuff. With the map filter, or function, replacing a loop is pretty easy with this function. For can be directly translated to the map function. It's up to you, whatever makes your code more readable. Alright, so what we have is an example of map, and we've created a function called the which one function, which needs a value given to it, and we've called that conveniently value. And basically all this def function says is if value is equal to 1, return a 1, otherwise return nothing. Remember we said sub-procedures is do something, functions return a value, so this is returning a value back. Then we have our actual program code. We said number, which is a list, again iterable because we iterated over this list previously, has three values, 1, 2, and a 1. And then we call the map function, which is a looping structure. Well, what it does, it wants a function given to it, and it wants some type of iterable structure. The function is which underscore 1, number is the iterable structure, and it's going to take in turn each value out of that iterable structure, pass to the function, do something. Going to take the next one, pass to the function, do something. It's going to do that 3 times. And then when we print result, we'll see the accumulated results of what happened, and it's going to basically tell you, hey, is it a 1, is it not a 1? Is it a 1, is it not a 1? And it should say 1, not 1, 1. Try the example out with the challenge as well, and then hit resume when you're ready. Very good. Let's try the exact same thing to see how that works with a for loop. This is going to perform the same function, we're just not using map. Try that out, and then we will look at an example with map to determine grades, letter grades. And then the last thing that I want you to try is map with strings. Again, we said strings are iterable. Hit resume when you're ready to continue. Alright, the filter function will return only values the function returns as true. So if you remember with map, it gave you a true or a false, right? Easy enough. Well, with filter, it's only going to give you the true values back. So what we've said here is return underscore true value. Again, we just argumentatively said value is what it's going to be. The variable is copied to it. Test is equal to value modulus 3. Alright, now, if you remember from good old binary logic, 0 false, 1 true, modulus returns the remainder of integer division, so it could be a 0, it could be a 1, right? Aha! Try that example out, and then we will move on. Alright, let's try the for instead of filter for that last example, just to see how that works. And again, these functions are looping structures. They're just alternatives to using a for loop. But you'll note after you try this, it does the exact same thing, just with a for. Try that out, and we will continue. And the last functions that we will look at is the reduce function. Function returns the pass value on each subsequent item in the list and stores the result in an internal accumulator or storage area. So basically, it's going to kind of sum everything up and put it in one, variable so that you can work with it. That's reduce. We have our def function, have what it does, and we also have something else, a lambda function. Think of that as a one-line, inline mini function. You could define it as a def, which could be multiple lines, put it at the top, call as many times as you want, or it could be you want to define a function for one-time use only, within a structure that you're writing. Maybe that's easier. So that would be an example of a lambda function. And we'll also try something, the classics, some factorials with the last example. You certainly want to know how to do that because most of the time you do that in any computer science course with any language. And when you finish that, try the hands-on activities at the end of the chapter to reinforce what you've learned. And I look forward, and Sebastian looks forward to talking to you on Chapter 10. Take care.